About the test. First off, we are going to make it a little bit larger, not the amount of questions, but the answer spaces will be bigger, and we're going to stretch it onto 3 pages so that you actually have room to work. Okay? This one we kind of wanted to squish it onto 2 pages just so that we only had to use 1 piece of paper. For the individual test, we will give you more space to work and more space to write your answer. Capiche? Okay. Now, I believe, don't quote me on this, but I believe we're also giving you this as opposed to just the first quadrant. Okay? So the first thing that I would do is I would come in here and I would label the first quadrant. 0, 30, 45, 60, 90. This is 0 radians. This is pi over 2 radians. 45 is pi over 4 radians. 30 is pi over 6. And 60 is pi over 3. Yeah? I have the point 1, 0, 0, 1. I know these guys are rad 2 over 2 and rad 2 over 2. This guy is rad 3 over 2 and 1/2, and this guy's 1/2 and rad 3 over 2. Okay? Should take you about 30 seconds to fill in the first quadrant. From that, I know all of my 45-degree angles are these middle lines, right? Yeah? So any angle that in degrees has a 5 at the end is most likely a 45-degree angle reference. If it has a 4 as a denominator, it's going to be a 45-degree reference. Okay. Some other things that I'm going to list here. Everything is positive here. This one would be negative, positive, so negative cosine, positive sine. This one's negative, negative. Both of them are negative. This one is positive, negative. I can also remember that all students take calculus stuff because I'm going to need all that. Okay? So, now I'm ready to go. I need to find the sine. Sine is the y value of negative 13 pi over 4. Do you notice that this has a pi over 4? That means that the reference angle is going to be what? 45 degrees. So in other words, I just need to find the sine of 45 degrees. What's the sine of 45 degrees? Root 2 over 2. And then I need to check if in this quadrant, whatever quadrant that angle is in, is sine positive or negative. So I do need to count out negative 13 pi over 4. So here we go. You ready? Negative 1, 2, 3, 4, right? 5, 6, 7, 8, 9, 10, 11, 12, 13. So negative 13 pi over 4 is in the second quadrant. Sine is what in the second quadrant? Positive. So my answer is positive. So? Good answer. Negative 3 pi. Well, let's think about this. I know that this over here is pi. Right? So if I'm going negative 1 pi, where's negative 2 pi? Right here. And negative 3 pi is right here. This is the point negative 1, 0. So what's the cosine there? Negative 1. Okay. Secant of 4 pi over 3. What's the reference going to be? Pi over 3, right? Secant is the reciprocal of what? Cosine. So what's the cosine of pi over 3? 1/2. So the reciprocal of 1/2 is 2. I just need to know if it's going to be positive or negative based on that quadrant. So let's see. If I count by pi over 3s, I've got 1, 2, 3, 4. So this is in the third quadrant. In the third quadrant, is secant positive or negative? Well, tangent's the only thing that's positive. Secant isn't related to tangent, so it's going to be negative. Okay? Again, you got to remember your references. That's something over 3, something over 4, something over 6. This is something over 6, something over 4, something over 3, something over 3, something over 4, something over 6. Nope, did that one backwards. Did I? No, I did it right. Okay. Cosecant, that's related to what? Sine. So I'm going to start off finding the sine, and then I'll figure out if it's positive or negative, and I'll flip it. Okay? What's the reference angle? Pi over 4. Pi over 4 is right there. What's the sine of pi over 4? Root 2 over 2. So root 2 over 2 is the sine. If I flip that, I have 2 over root 2, multiply by root 2 over root 2, and that gives me 2 root 2 over 2, which simplifies to what? Root 2. Now I just need to figure out in that quadrant, is sine positive or negative, because that'll tell me what cosecant is. So I'm going to be counting by the fourths. How many fourths are there in a half a circle? 4 in a half a circle, because if it gets to pi, it has to get over to 4 fourths, right? So 8 in a full circle. So let's see, we're going in negative. 1, 2, 3, 4, 5, 6, 7, 8. Another 8 would be 16, right? 17, 18, 19, 20, 21. Second quadrant, sine is positive, therefore cosecant is positive. My answer is just root 2. Okay, got to be familiar with counting those things around the circle. If not, you can always draw the graph of it. You can always draw what the angle looks like, figure out where the terminal side is. That's really what you need to know, is what quadrant is the terminal side in. Okay, all right, cotangent of 210. All right, let's see, 210. 180 is 210 right here? I think it is, isn't it? What's the reference angle? 180 to 210? 30 degrees, right? So I need to take the tangent of 30 degrees and flip it. Is it going to be positive or negative in that quadrant? Third quadrant, tangent is positive, therefore cotangent is positive. So let's find the tangent of 30 degrees. That would be sine over cosine, right? That's tangent. What does that simplify to? If I write it like that, that becomes 1/2 times 2 over root 3, which is 1 over root 3. Now, I'm not going to simplify that right now because that's the tangent. I don't want the tangent, I want the cotangent. So I want the reciprocal of that. What's the reciprocal of that? Root 3, and because it was in quadrant 3, we already determined it's going to be positive because it's related to tangent. So? All right. Tangent of 11 pi over 6. Negative 11 pi over 6. So I'm going to be counting by pi over 6s. Now remember, in a half a circle, I have to get 6 over 6. So that means there's 6 of them in a half circle. When I was dealing with fourths, there were 4 of them in a half circle. When I'm dealing with thirds, there are 3 of them in a half circle. Okay? So let's see. 6, I need to get to 11. Well, if this is 6, 7, 8, 9, 10, 11, we're back to the first quadrant, aren't we? Everything's positive in the first quadrant. That makes life easy. My reference angle is what? Pi over 6. So let's see. I just need the tangent of pi over 6, and I'm good. Didn't I just find the tangent of pi over 6? Because that's the same as the tangent of 30? Yeah? So now I actually just do need to simplify this, and I got my answer. What does that give me? Root 3 over 3. So if you can find one you've already done the reference angle for, that helps. All right, cotangent of 135. 135 ends in a 5. My guess is then it's a 45-degree reference angle. Where's 135? Happens to be right here. 135 degrees. So yes, it does have a 45-degree reference. What do I know about the second quadrant tangent? Sine's the only thing negative, so tangent is, sine's the only thing positive, so tangent is negative, therefore cotangent is negative. What's the tangent of 45 degrees? Root 2 over 2 over root 2 over 2? 1. So what's the cotangent? The reciprocal of 1, which is still 1. Easy peasy? What if you get a fraction, if you're finding, if you're reciprocating something or you're setting up a tangent or a cotangent, that ends up like that, 0 over 1, or 0 over anything for that matter. What does that become? Nope. It becomes 0. What's the reciprocal of 0? Isn't the reciprocal of 0 1 over 0? And that is undefined. Okay, so please note that difference. The reciprocal of 0 is undefined. By the way, something I didn't mention earlier, but if you are late tomorrow to class, you do not get extra time on the test. So if you want the full period to work on the test, then get here when class starts. Okay, you will not receive extra time. All right. I did correct this, that this was a typo. It should not have said sine there. I should have whited it out before I copied it. Because we actually need to find all 6. Now, for my sanity, as I am grading these, I would appreciate if you tried to remember to go sine theta, cosine theta, tangent theta, in that order. And then do the appropriate reciprocals on the right. What's the reciprocal of sine theta? Cosecant theta. What's the reciprocal of cosine theta? Secant theta. Most of you went in this order anyways. Just saves my sanity. Because otherwise I have to stop and look, okay, wait, where's your sine? Where's your cosecant? Where's your cosine? It takes forever. Okay, so same thing down here. Will I take off points if you're missing the theta? Yes, because that's like an incomplete sentence. It doesn't make sense. So again, down here, sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Okay? All right. For the triangle problem, guess what? Everything is positive. Only when we get one here that actually has a quadrant to worry about do we need to worry about what's negative. Okay? So in my triangle, everything is positive. So all of my values over here are going to be positive. First thing I need to do is find the missing side. How do I find the missing side? Pythagorean Theorem. So 3 radical 13 squared plus whatever that other side squared is 21 squared. Well, let's see. 3 radical 13 squared. I have to square both the 3, that gives me 9, and the radical 13. What's radical 13 squared? Plus b squared equals 21 squared. Now, here's where I can get my calculator out, if I'm not too comfortable with that. 21 times 21. Yes, you have to do it old school there, because there's no squared button. And over here I have 9 times 13, 117, plus b squared equals 441. What do I do at this point? Subtract 117. So b squared equals 441 minus 117, 324. And guess what? This calculator will take a square root for you. I just have to type in the 324, which is already there, and then press the square root button. And guess what the square root is? 18. Yes. Questions about that? Again, how do you take a square root on this calculator? You type in the number you want to take the square root of. Like if I want to find the square root of 4. Then you press the square root button and it tells you what the square root is. Okay, got to do it backwards. So I have a side that is length 18. So, what am I going to fill in here? 18. Let's find the sine. Sine is opposite over hypotenuse, which is 18 over 21, correct? Can I reduce that? If I can, I must. 18 divided by 3 is 6. 21 divided by 3 is 7. My sine is 6/7. So what is my cosecant? 7/6. Excuse me. Cosine is adjacent over hypotenuse. Can I reduce that? 3 over 21 becomes 1 over 7. That gives me rad 13 over 7. That's my cosine. Rad 13 over 7. How do I find secant? Flip it and simplify. That would be 7 over rad 13. Multiply by rad 13 over rad 13. That gives me 7 rad 13 over 13. Again, I will make the answer spaces bigger for your test. There we go. So far, so good? Tangent. Opposite over adjacent. What is opposite? 18 over 3 rad 13. Can that reduce? Yes. That becomes 6 over rad 13. Now, that's what my tangent is. I'm going to fill in my cotangent right now, though, because my cotangent doesn't need any simplifying. What's my cotangent? Rad 13 over 6. It's just the reciprocal of this, right? Now let's simplify our tangent. Multiply by rad 13 over rad 13. That gives me 6 rad 13 over 13, and that's my tangent. Questions there? Yes or no? Okay. You ready for this guy? Yes.
So in order to find the cotangent and the secant, if it has like a radical in it, you have to use that method where you put the square root over the square root thing.
If there's a radical on the bottom, you always have to do this.
On the bottom?
Uh-huh. On the top is fine. If there's a radical on the bottom, you have to do this. This is called rationalizing the denominator.
Oh, okay.
Okay? All right. So, here is our given point 1. What quadrant is this in? Quadrant 4. And what do I know about what's positive in quadrant 4? Cosine is positive, and therefore secant is positive. So sine is going to be negative, cosecant is negative, tangent is negative, cotangent is negative. I fill those in at the beginning so I don't have to think about it later. Okay? What do I do at this point? I go from this point and I go where? I make a line to the x-axis, always the x-axis. That makes a right angle. Yes? What do I label this side right here? This side is on the x-axis. What is it? 8. This side is parallel to my y-axis, so what is that one? 2. Ignore the negative. We already took care of the negatives over here. So I have a triangle with a leg of 8, another leg of 2. How do I find the hypotenuse? Pythagorean Theorem. What is 8 squared? Plus 2 squared is 4. That's 68. So then I come over here and I say 68 square root, and it gives me a decimal, and people come ask me, what do I round it off to? You don't round it off. If it gives you a decimal, then you draw a tree. So let's see. 68 is 2 times what? 34. 34 is 2 times 17. So what does C equal? 2 rad 17. That is my hypotenuse. No decimals allowed anywhere. Okay? So let's see. I'm going to draw this triangle a little bit bigger just so that I can see things a little bit better. So do you see that that's identical? I just blew it up over here. So this is 8, this is 2, and this is 2 rad 17. Which angle is theta? The one closest to the origin, the one that has the vertex at the origin. So that's this guy right here. In my drawing, it's that guy right there. So sine of theta is opposite over hypotenuse. Those two will cancel. That leaves me 1 over rad 17. I need to do some simplifying of that denominator, right? But before I do that, let's do the reciprocal. So what's the cosecant? Negative rad 17 over 1, which is just rad 17. Now I'll simplify it. That gives me rad 17 over 17, and it's got a negative sign that I had in there from before. So negative rad 17 over 17. Questions there? Okay, let's do cosine. Cosine is adjacent over hypotenuse. That can reduce before I simplify it, can't it? 4 over rad 17. Now I'm going to do the reciprocal first again. Yeah? What's the reciprocal going to be? Rad 17 over 4. And now I'll simplify it to find the cosine. Multiply by rad 17 over rad 17. That gives me 4 rad 17 over 17. And both of those values were positive because that's what's positive in quadrant 4. Tangent. Opposite over adjacent. What does that reduce to? 1/4. So tangent is negative 1/4. What's cotangent? Negative 4. Any questions about those guys before I go to the back side? What did I need my calculator for? Basic multiplication, right? 9 times 13, 21 squared, nothing big. All right, back side. Write the equation of the function shown. There are 2 of these, one in degrees and one in radians. First thing I'm going to identify is where is my midline. In this one, my midline is right there. What's that value? That means the k value is 4 when I write my equation. Or in other words, I'm going to write my equation and there's a plus 4 at the end. Right? What about this guy? Where's my midline here? Negative 1. Again, your midline is the halfway point between the maximum and the minimum. So if my midline or my k value is negative 1, then my equation is going to have a minus 1 at the end. Questions about that? What if my midline was at 0? Then there would be no k value. There would be no number at the end. You would just leave it blank. Okay? Yes?
Do we have to highlight it?
Do you have to highlight it? Here, no. Here, yes. Okay? All right. So I have my midline. What can I say about my amplitude? That would be this distance right here, or this distance right here, which is the same. What is that distance here in this problem? 2. So I have a 2 at the beginning. Now I need to know if that's a positive 2 or a negative 2. Where do I start looking at whether this is a sine or a cosine? I start at the y-axis. Some people were starting over here going, oh, it starts at the top. No, that's not where the y-axis is. This is starting in the middle, which tells me what about the kind of function it is. It's a sine function. Now, I know sine is middle, top, middle, bottom, middle, right? But this isn't going middle, top. It's going middle, bottom. What does that mean? It means that that 2 is negative. Okay. Last thing I have to find is usually the hardest. I need to figure out how long the period is, right? And then since we're in degrees, I have to set 360 divided by b equal to whatever that period is, and then solve for b. So how do I know how long the period is? Well, it's middle, top, middle, bottom, middle. So middle, top, which is now bottom, middle, bottom, middle. This is the end of one period. Do you get that? What is that measurement? 1080. So I set this equal to 1080. Let's solve for b. So I multiply by b. 360 equals 1080b. Divide by 1080. And I'll get b. So let's see. How can I figure out what this will reduce to? Well, I'm going to start off by saying 1080 divided by 360. Oh, it looks like I can divide them both by 360. And that reduces to 1/3. So my b value is 1/3. How does that look right here? Because it has to have a theta with it. So how do I plug in 1/3 times theta right here? Theta over 3. Okay. Now, could you reduce this a different way? Yes, you could divide by 10 and get 36 over 108 and then divide by 2. You could reduce it however you feel comfortable reducing it. Just know that this is the calculator you have to work with. Okay? Yes?
How did you get a negative amplitude?
How did I get a negative amplitude? Because my sine pattern is middle, top, middle, bottom, middle. But I notice here that it went middle, bottom, middle, top, middle. So it's not following that pattern. It's flipping the T's and the B's, which means that my amplitude has to have a negative in front of it. Okay. All right, let's look at this guy. What's my amplitude? How high is it going or how low is it going? 3. So I have a 3 out in front. I'll decide in a minute if it's positive or negative. Where do I start looking for the period? At the y-axis. Is this sine or cosine? Cosine, why? Because it starts at the top. So top, middle, bottom, middle, top. Top, middle, bottom, middle, top. That's the end of one period. Is it following this pattern or is it reversing the T's and the B's? It's following that pattern so the 3 can stay positive. If it was starting at the bottom, then it would be a negative 3. All right, what is one period? Pi. So just like I did here, I'm not going to set 360 over b. I'm going to set 2 pi over b is equal to pi. This is going to help me find b. Multiply by b. So 2 pi equals b pi. And divide both sides by pi. And what does b equal? 2. So right here I write 2 theta, and I'm done with my equation. Okay? All right, let's get to our graphs. Graph using radians for the first 2. All right, I'm going to fill in some information here. What is my amplitude? 2. My amplitude is not negative 2. Negative just tells me the pattern I'm following. Okay? This one is a cosine, so it's a Teenage Mutant Ninja Turtles. However, with the negative, that's going to make the T's into B's. and the B's into T's. Right? Let's see, what's the domain going to be? All real numbers. How do I find the period? Well, if we're doing radians, I need 2 pi divided by what? 1/6. What's 2 pi divided by 1/6? What's 2 divided by 1/6? 12 pi. So that means the 4th line out is 12 pi. And my period down here is 12 pi. So what's the 8th line out? 24 pi. Right? All right, what's half of 12 pi? 6 pi, half of 6 pi. So we're counting by 3 pi's. 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, 18 pi. I'll make the graphs bigger too. 21 pi, so you're not all squished in there. If you're worried about being too squished in, just write your label down here. That way it doesn't make your graph all difficult to read, and it's clearer to read down there without the grid lines. So if you're concerned about that, just write it down here. All right, I need to go, let's see, where's my midline? Midline is, there's no k value, so what does that mean? It's at 0. And I'm going to be going up how far? To 2, and down to -2. So here we go, starting. Bottom, middle, top, middle, bottom. And then my next cycle, the first bottom is already graphed because it's the last one of the previous one. So bottom, middle, top, middle, bottom. Now, a lot of people were drawing arrows going down at the end. So they would get this part decently, and then they would just continue going down. That's a problem. They would go down like this. I'm going to mark that off because that doesn't fit your range. What's happening at the end here? It's curving back up because it's going to continue on with another cycle. So I don't want to see those arrows going down. What's my range? -2 is less than or equal to y is less than or equal to +2. So? All right. Next one is a one-cycle graph. This is written backwards, though. Do you see that? It should say sine 2 theta minus 1, which tells me what? I have a midline where? -1. By the way, do you notice that I even drew the midline when it was at 0? I appreciate you drawing in the midline with the highlighter, even if it's at 0, because then I know you're looking at it. Okay? I know you've explored everything. All right, what's my amplitude? 1. What's my domain going to be? All real numbers. Let's find that period. We're still in radians, so it's going to be 2 pi divided by b. What's b? 2. So what's the period? Pi. So I'm going to label this one down here just so it doesn't get involved in everything. The 4th line out is pi. What's halfway from 0 to pi? Or 0 to 1 is half pi, right? Or pi over 2. What's half of a half? Pi over 4. So 1/4, 2/4, what would this one be? 3/4 or 3 pi over 4. And there's my markings. On the y-axis, what do I need to mark? Well, I need to start off by marking where my midline is. And then my amplitude tells me I need to mark 1 line above there and 1 line below there. Okay, this is a sine graph, so it's middle, top, middle, bottom, middle. Is it going to stay that way, or am I going to switch the T's and the B's? Stay that way. So, middle, top, middle, bottom, middle. Now, I'm not going to hook these ends. Why am I not going to hook this end right here? Because it's still got to go up a little bit to get to the next top. And this one's got to go down a little bit to get to the next bottom. Excuse me. What's my range? -2 is less than or equal to y. It's less than or equal to 0. Yes, those always have to be in order from least to greatest. Yes. Uh-huh. Yes. How did I get what? Pi for the period. We're talking about radians, so you always do 2 pi divided by whatever b is. So here we did 2 pi divided by 1/6. Here we did 2 pi divided by 2. And that gets me pi for the period. Yes?
Does this mean theta is 1?
Say that again?
Theta equals 1?
Theta varies. Theta's like x. Like if you graph a line y equals x, x can be anything. If I wanted to say what is y when theta is 1/4, well, you'd go, or theta is pi over 4, then you'd come here, pi over 4, theta is 0. Or I'm sorry, y is 0. So we're not actually getting an answer for theta, we're getting a graph of all the possible answers for theta. Or all the possible answers for y, depending on what theta is. Okay? All right, last two. Graph using degrees. So that just means that instead of doing 2 pi over b, I'm going to do what? 360 over b. So let's see. 360 over b. What's b in this case? 3. What's 360 divided by 3? If you're concerned, use your calculator. 120. So what's the period? 120 what? Degrees. How do you write degrees? You put a little circle there. Put a little circle there so I know you're talking about degrees. Because 120 could also be an amount of radians, technically. What's my amplitude here? 1/2. Now this one's a little bit of a pain in the butt because it's 1/2. So here's what I'm going to do. I'm going to label every other line as 1. So that means I'm going to have 1, and this first line is going to be 1/2. And what's the third line going to be? 1.5, which is also known as 3/2, right? 1/2, 2/2, 3/2. This would be 4/2, which is 2. What is my k value? 1. So I have a midline right there. Okay, so far so good. I have a cosine graph, which is my Teenage Mutant Ninja Turtles. Is it a positive or a negative? Meaning, am I going to need to switch those t's and b's or not? No, I'm not going to need to switch them because that's positive right there. So, if I'm going up 1/2, that would be top, middle, bottom, middle, top. There were a lot of groups that somehow put their point that's supposed to be at 1/2, they put it on the x-axis. You can't do that. The x-axis is 0, not 1/2. So, at the end of this graph, are my arrows going to be going up, or are they going to be hooking back down? They're going to be hooking back down because they're starting and ending at that maximum value, so they can't go up any further. So that's what my graph looks like. Now, why did I draw my graph before breaking up my x-axis? Because I didn't want to crowd things. My x-axis I can label now safely. What do I label the fourth line out? The period, right? What's the period? 120. What's half of 120? 60. Half of 60. So what's my remaining measurement? 90 degrees. What's my domain? And my range. 1/2 is less than or equal to y is less than or equal to 3/2. No decimals. I've not had decimals anywhere on this test. All right, last one. What is my amplitude? 3. Is it -3? No, my amplitude always has to be positive. The negative just tells me that instead of doing my usual sign, which is middle, top, middle, bottom, middle, I need to change it to middle, bottom, middle, top, middle to get those T's and B's switched. Okay? Where's my midline? 0. So K equals 0. What's my amplitude? My amplitude's 3, which means I'm going to go up to what? 3. Please label that line. And down to what? -3. So label that maximum and that minimum point for me, please. Now let's find the period. 360 divided by B. What is B? 1/4. I know that that's 360 times 4, right? 360 times 4 is 1440. So, I'm going to write these very carefully. You ready? Fourth line out. 1, 2, 3, 4 is 1440. What's half of 1440? I can divide by 2. 720. Divided by 2 again is 360. So once I have that first marking, I know it's counting by what? 360s. So 360 plus another 360 plus another 360. 720 plus 720 plus 360 is 1080. And I can keep going. These are all degrees, by the way. Degrees. 1440 plus 360 is 1800. By the way, where should I end up? 2 periods. And if one period is 1440, isn't 2 periods 2880? Okay. Let's go back to where I was. 1800 plus 360, 2160. Plus 360 again, it's 2520. And if I add 360, I should end up at that 2880. Okay. All right, so the period is 1440 what? Degrees. Put your degree symbol. All right, I think I'm ready to graph. Middle, bottom, middle, top, middle. Now, some people got off with their graphing on this next period for some reason. It's like they went straight from the bottom to the middle, and then they went all the way back up to the top for their next point and got off. Make sure you're graphing every point. Middle, top, middle. You got to end up at the bottom there. Or, I'm sorry, at the middle. So, these endpoints are not hooking around because they're ending in the middle. You need to signify that they're continuing on towards that maximum or that minimum value. So make sure you're putting those arrows. What's my domain? All real numbers. What's my range? -3 is less than or equal to y is less than or equal to 3. Okay? All right. Happy studying.